Hello, everybody, and welcome to our live demo. Um, we are going to give it another minute just to let some other people join, and then we're going to get started today. So just a couple seconds, we'll get going. People are coming in. So hello, welcome to today's live demo of DataRobot. Some of the capabilities that we have for organizations in our public sector. Good morning, good evening, wherever you might be. Before we get started, just a little bit of housekeeping that we're going to take care of. First, this will be a recorded demo. It will be shared. So if you miss something, want to go back to something, want to share it with all of your friends, please do so. You will get that in an email following this event. And then also questions will be answered at the end of the demo. You can put them in our Q&A chat, and we will be able to take those at the end. So without further ado, we are excited today to have Andrew Mathis here with us. He's going to walk us through this demo. I'll let him introduce himself, but he is one of our applied AI experts here. He's a team lead working specifically with federal government solutions and federal government customers. So we're very excited to have him here with us. And with that, Andrew, I'll turn it over to you.
Thanks, Rebecca. Hi, everyone. I'm Andrew Mathis. As mentioned, I'm one of our applied AI experts on the federal squad here at DataRobot, and I have supported federal customers across DoD, IC, civilian sector for the past 6 years at DataRobot. And so I'm very excited today to step you through a vision of the types of AI applications that can be delivered with DataRobot for federal and public sector clients. So with that, let me start sharing my screen and we'll dive in here. All right. So what we're going to be going through today is an example of an application based on a use case that DataRobot has delivered at least twice now with federal government customers, both the Army and the Navy, targeted around contract finance. And so what we're imagining today is that we are a contract finance team with a portfolio of contracts whose spending and funding we have to manage. And in this portfolio, we're going to use this AI-powered application to get prospective views on our contract performance and understand which contracts are going to be most at risk for having excess funds at the end of their life cycle. And this is really important because if we can identify which contracts are likely to have too much funding left on the table at the end of their life cycle, we can reallocate those funds to other requirements where those funds could be better used. So what we have here is an application running in DataRobot that shows us our portfolio of contracts. We've got an aggregate view here of how many contracts we have that are high versus medium versus low risk for unspent funds. And we can dive into detail in the table here to look at the particular contracts that are at highest risk. So imagining I'm a contract finance specialist here, let's dive into, let's say, our Army contracts and see which ones are at highest risk for having excess funds so that we can make some interventions here. So I'll start by diving into this top contract here. And what I get from my application here is a description of the contract, the predicted risk level of excess funds as determined by our predictive AI solution, and an explanation of why that contract is determined to be at high risk for having excess funds. So in this case, we've got a contract that only has 40% of its funds obligated so far in the life cycle. That is contributing to an increased predicted risk of having excess funds. The award amount size, this looks to be a rather large contract in terms of award amount, so that also is contributing to a higher risk. And the project type here being K6, categorization of contract types, that also leads it to be a higher risk for excess funds. So what I'm getting from DataRobot's predictive AI solution here is both the risk prediction itself and a story of why. What are the particular aspects of this contract that are leading the predictive AI solution to determine that it's high risk? Now that I know that this contract is likely to be have excess funds at the end of its life cycle, I might want to do an intervention. Maybe I want to alert the particular contract manager that oversees this contract that there's a risk of having excess funds at the end of its life cycle. And now what I can turn to is a generative AI solution powered by DataRobot. So with a couple clicks here, I can generate an email to send to a contract manager that summarizes the state of play here and what those risk factor predictions were and the reasons why. So you can see here in just a couple seconds, we generated an email summarizing all of this predictive AI insights for my contract manager. And if I want, I can change around the verbosity of it or maybe the style. Maybe I want a more playful email draft to catch the attention of my contract manager to intervene here. And again, all this data is going to be sent to the generative AI solution running in the background here to generate a new email text that in this case has a more playful language, will catch the attention of our contract manager. So behind the scenes here, we've got this production application that is running in DataRobot, powered by both predictive and generative AI solutions. So now I'd like to step behind the scenes to see how did we get at this predictive deployment that's providing the contract risk profiles, as well as the generative AI deployment that's helping us generate quickly that customized email text. So let's peel back the onion here and see how did we arrive at these AI solutions powering our production application here. So for starters, I'm going to look into my DataRobot workbench. So this is going to be the central place for my AI development workflows. So in a use case here, I can pull together all my development assets. I can collaborate with my colleagues, all working together to build AI solutions here. And for our predictive AI solution, so that's the AI solution that's reading in contract data, determining which are at high risk for excess funds, I'm going to start with some historical training data. So pulling in from my data warehouse or local files, whatever data source I have, I'm going to pull in historical information on contract financial performance. So for example, here I've pulling together a few different tables from my database, doing some joins, removing features, computing new features, all within this graphical data wrangling experience here. So even if I maybe aren't as familiar with SQL code or writing Python code to prepare my data, DataRobot is going to give me my tools to prepare and slice and dice this data to get it into the state that I'm ready to build a predictive model. Once I've got my data in order here, I'm going to move into the experiment interface for DataRobot. And this is going to be where I'm going to set up the bounds of the problem I'm trying to solve and clue DataRobot into what kind of predictive AI I'm trying to do today. So in this case, I plugged in my target feature of excess funds. This is a binary classification problem. I'm going to ask DataRobot to figure out the pattern behind which contracts end up having excess funds versus not, 1 versus 0. Just one of the many types of predictive AI problems that DataRobot can engineer for us. And just by pulling in my data and telling DataRobot what it is that I want to predict, I can continue with the experimentation process and start the modeling procedure. And what that's going to do is use DataRobot's powerful automation to explore a wide solution space of predictive AI approaches, fit them against each other in a survival of the fittest competition, and give me the results of which predictive AI approaches work best for my particular problem. So at the end of that process, I'm going to get a model leaderboard here of all the different approaches that DataRobot automatically explored for me, where I see them racked and stacked against each other, and I can figure out very quickly which end up being most effective for predicting which contracts are going to have excess funds versus not. And in my experiment interface here, as a data scientist, I can evaluate this model, understand how well is it performing, what are my true positives, my true negatives, false positives, false negatives, to really get an understanding of how well is this model going to do in production at recognizing those contracts with excess funds. And additionally, I can step through here and get all my insights about what this model learned. So what are the particular aspects of contract profiles that the model's picking up here to determine which have excess funds versus not? Looks like it's getting into the project type and the obligation amount, the award amount. All of these are feeding into the predictive performance of my model. Similarly, I can dive into feature effects to figure out what are the precise patterns the model learned. So as we look at project type here, which project types were determined to have the highest versus lowest risks for excess funds? Again, all the tools I need to understand what this model is doing and have the confidence to push it into production so that I can integrate it with that application you just saw. Once I've determined that, yes, this is a model I'm comfortable putting into production, with just a couple clicks here, I can register the model. That's going to get all the model's different assets and metadata logged into our model registry, governed. I can then share it with reviewers, and eventually, if everybody's on board, with another click here, deploy that model into production. And what that's going to do for me is wrap up this predictive model into a production API service that's going to present that API for any external consumer to use, whether that is the application that you saw in the beginning of the demo here, or an external process or user that wants to call that API. And what that's going to do is present me in my deployment console this production grade predictive service. And with this deployment console, I'm going to get all the data I need about understanding, all right, who deployed this model? What assets did it use to get to deployment? Traceability to have full understanding of what are feeding these predictions. And along with that, I'm going to get this enterprise grade observability and monitoring so that tracking over time, I get all the information I need to keep this model healthy, recognize when things start to go wrong, and intervene to get a better model into production. So that extends to both data drift, so tracking when the world is changing, the data coming in at production time starts looking different than when I trained the model, because that's a key indicator that I need to get updated data and an updated model into production. And it also extends to tracking accuracy over time. And then using the powerful mitigation features of DataRobot, I can even have multiple candidate models side by side as challengers to track their respective accuracies over time, figure out when there is a better model ready to go, that produces better accuracy in production and then seamlessly switch that out. So we've got all the tools here necessary to start from our historical data, rapidly arrive at a predictive AI solution that's performant, get it into production, and keep it healthy once it's there. All right, so that is a very brief look at the predictive aspect. How did we get these risk predictions for risk of excess funds? Now let's turn to the second aspect, that generative AI feature for generating those email texts. Again, I'm going to start in my workbench here where I can develop my AI solutions. And this time I'm going to hop into my generative AI playground. So this is an interactive interface where I can pull together all the parts and pieces for a generative AI solution. So I can explore my choice of LLMs to integrate here. So here I happen to be comparing GPT-4o to Claude 3 Opus. Experiment with different settings like system prompts or temperature settings to craft together a generative AI solution that's going to produce, in this case, the types of emails that I want to pull into production for that production app. So I can give some example prompts here and see how these different generative AI approaches generate emails. You can see here, for example, the Claude 3 model seems to be using a couple more emojis in the output. Maybe that's going to influence how my choice of which generative AI solution here I want to put into production. And alongside this more individual level investigation into the performance of handcrafting these inputs, I can also generate aggregated metrics through automated compliance tests. So in this case, I want to throw a bunch of different tests against these solutions to see how vulnerable are they to jailbreaks? How vulnerable are they to producing potentially toxic output? So with my automated compliance tests here, I can run one of many different tests here to evaluate my different generative AI solutions for different types of performance issues or vulnerabilities, again, to gain that confidence of which solution should I push into production. Once I've run those tests and I'm ready to go, I can again send my chosen approach to the workshop, register that model, collect together all those automated code assets that were generated for this generative solution. And I can configure evaluation and moderation tools that I want to wrap around my production service. So for example, I might want to add in prompt injection guards that look at potentially malicious input coming in, catch that, interrupt that before it reaches my generative AI solution to prevent that from being manipulated. And as you can see here, we have a wide menu of approaches available to guard the inputs and outputs of our generative AI solutions, and the flexibility to build in custom deployments as well for any kind of customized guardrails you might want to pull in. And again, that's going to end up with a production grade API service serving up those APIs necessary to take in new contracts and predictions and generate those emails. And again, this is a REST API that can be called either in that DataRobot application you saw or external applications just as well. And just as with the predictive AI, I'm going to get all the observability and monitoring I need to watch this service in production, understand how it's doing over time, and the traceability to govern the solution. So for example, if I want to hop into understanding those prompt injection guards, I can actually go through and look at historically what were the particular prompts coming in that triggered my prompt injection guard so that I can then refine my approach, understand what's going on with this solution, keep it healthy and safe over time. All right. So what you just saw in the demonstration here briefly was a production AI application for contract risk management, being able to pick out those contracts at highest risk for excess funds, leveraging predictive and generative AI to deliver those insights to our decision makers that need to take action on them. And through this demo, I hope you were able to see how DataRobot helps you not just develop these approaches in the first place, but get them into deployment quickly, into production, and keep them safe and monitored once they're there. So with that, let me open it up for questions from our audience.
All right. It looks like we have a couple of questions to cover, so I'm just going to fire them at you, Andrew, and we'll see how it goes. Let's start with how do AI applications built with DataRobot comply with responsible AI requirements?
Yeah, absolutely. This is a crucial aspect of any AI development for these crucial public sector applications. And so, as you got a preview through along the demonstration, woven into the complete development and deployment process of DataRobot are the types of transparency and traceability tools you need to, both at development time, verify that the models you're developing are doing what you think they're doing. Are learning the right kinds of patterns from your historical data, and in production time, arming you with the tools you need to watch them so that if they stop working, you know immediately and you can intervene quickly. So both that development time and production time guards and traceability are what you need to responsibly operate AI for these crucial applications.
All right. Another question. Can we use DataRobot to predict the stock forecast? If yes, what is an accurate percentage?
That is an excellent question, and actually one that very commonly comes up when seeing these predictive AI capabilities. Now, can DataRobot do time series forecasting? So watching historical trends of something like a price going up and down or quantities going up and down and make a time series forecast. Absolutely, DataRobot has very powerful time series forecasting capabilities. Now, for particularly the stock market prices, is that truly forecastable based on historical data? Many people have tried this, and I will caution you that stock market prices are not inherently predictable based on historical data. If they were, there would be people making much more money in the stock market than they are. And that brings up a great point of these powerful tools will give you the ability to iterate quickly, find your historical data, prepare it, evaluate different solutions, and get the transparency of how much can I count on this model to give me accuracy that I need. And then with all that transparency and insights, it's going to be a contextual decision for your particular domain and process. Is that going to be enough to put into production and get you the value you need?
Excellent. I wish I could predict the stock market. Okay. So how do you monitor model drift and retrain pipelines to keep predictions accurate over a period of time?
Yeah, absolutely. So you saw a little bit of that in our data drift monitoring, and that's one of the tools we use to, for example, compare that data coming in at production time to the training distributions. So we use some statistical methodologies there to compare all the data coming in, see if it's different, and if so, alert quickly to decision makers that, hey, something's changed. And building on top of that, we have a wealth of continuous AI retraining capabilities so that either on a schedule or based on those alerts from the monitoring infrastructure, you can set up retraining pipelines to automate that process of going back to your database, getting updated data, exploring that solution space, getting a new model ready to put into production, and perhaps adding it to that challenger model framework to see how's that going to work against your production model. So you've got all the tools in your toolkit needed to recognize those problems when they occur and respond very quickly to get a new model into production.
All right. We have one more. What guardrails does the platform provide to prevent malicious users from abusing Gen AI components?
Yeah, this is a very popular topic, as I'm sure all of you have seen the horror stories of generative AI solutions put into production and having unwanted behavior or being manipulated into doing the wrong thing. So we touched on this briefly, but there is an extensive library of guardrails that you can put both in front of the inputs to generative AI solutions and watching those outputs. And so with those, we can build in checks to say, recognize prompt injection or manipulation attempts before they even reach your generative AI solution, block those at the source, and log them for traceability so you can follow up later to see what kind of malicious activity is being attempted. Also on the tail end, we can add in things like hallucination detection. When does your generative AI solution start giving answers that are unexpected or unusual? We want to watch those outputs as well to catch those problems that are arising. And then beneath all of that is the flexible framework to introduce custom components as well, because naturally, especially in the government domain, the types of malicious behavior that you're worried about coming in, or the types of hallucinations coming out, may be domain specific. And that's okay, because what you have with DataRobot is a customizable framework to build in particular guard models that catch that specific type of problem for your domain and add that into the menu of options of guards that are protecting your solutions.
All right. Well, I think that's all the questions we had. Thank you, Andrew, for the wonderful presentation and answering all the questions from the folks here. Thank you all for attending and spending a small part of your day with us today. If you have further questions, please reach out and ask those. As mentioned at the beginning, this was recorded, so you will get an email following that will have both the recording and links out to learn more about DataRobot and specifically DataRobot in the public sector. You can request a demo. We have a free trial available. So please do those things. And again, thank you for the time today. Have a good day.